and I will how can I turn it on? Hello, hello, hello. Yeah. So today we will talk about some different type of cloud services. I will try to make as much as possible to give different examples from different cloud providers. But if you have questions, you can just stop and ask. I will not introduce myself. I already did it one time today. So today we will talk some basic components. And as a disclaimer, these all of the information I will share you is my personal experience. So my information may be unupdated. So if you want to do some professional thing, let's check before deploy something. So what is the common cloud providers? We have three of them in the world right now. It is GCP from Google, AWS from Amazon, and uh, Azure from Microsoft. Also, we have millions of other cloud providers as well, but these are the most common three of them. And uh, if you notice something, most of the e-commerce companies or most of the big tech companies have cloud providers. Do you guys know why? Any theories?
Make money. It makes money.
It makes money, but it's actually their need. So a couple of decades ago, these companies start to run their servers, like Amazon, while running their e-commerce website. They need to run their servers, so they needed some system, some automation for running servers. So they just say that, hey, we needed something that we can manage these servers because it's not easy to manage all of them by hand. So they start to write automation scripts, and they start the first class we ever know today. And then after one point they say, oh, we just like Google says, oh, we just managing like Gmail, YouTube on this like internal Google Cloud thing. Maybe we can also open this to outside and make money. And also Amazon is the same. Amazon has their own technical challenges to fix about data centers. Because there's a couple of teams in the company, like software teams, just want to create instances like this. But when they want to launch an instance, it's just like you just go the infra guy that purchase the hardware, put the cables and everything. So uh, that's why they actually create this class for fixing their problems, and they start to sell publicly. And then they notice that, oh, they are making a lot of money than their actual business. And the first concept I want to introduce is infrastructure access management, or identity and access management. Like most of the cloud providers, the name is same, but definition is a little bit different. So this is the thing that the all access management is happening. For example, you have a teammate and you want to give access to teammates, but only a couple of servers. You will do here. You have a one database, and this database has to be used by a guy in the finance department. So you are giving access to guy here. You have a one backend application which has to connect to the a database. You are giving access from here. So this is the general place that you manage the all of the access. And I don't mean only like creating a password and usernames and giving the teammates. I mean like creating a policies and giving adjusting these policies tailor made for some roles. We have some thing named roles. So the role says like my role in this company is a DevOps engineer, or your role in this company is a finance guy. So finance guy just like access to some couple of systems, but as an engineer, I can access other different services. And you can just create these roles, and you can just write a policies, and policy can say this guy can access this server, but this guy cannot access this server, or this guy can access the production database read only, but can access the development database full access. So after creating this type of policies, you assign these policies to roles, and you assign these roles to some people or some services. For example, let's assume a role. It's a production role. It has a policy that reading and writing a production database. And you can assign this role to a backend, a server. And this server can connect the database without username and password because you give access in access management to this server. But this is only working if you're inside the cloud. So you cannot say that, hey, I have a computer in my company and I want to give access to like free database access without a password to this computer. No, you cannot. But if you're running a machine, a EC2 or a Lambda function inside of your AWS or Azure account, you can just give a specific roles to these instances. So we will probably Friday, when we are doing a Kubernetes, we will do a demo with how this is work. And I think we have question. Do you have question?
Yes, I was wondering if you can, or if you will, explain how does it work internally, the magic that happens so that you have access to the computer. How does how does it work internally so the access is granted? Is it AWS adding the SSH key to the machine and this is how you gain access, or or is it something else that happens inside the?
Well, it's actually a really long topic, so I don't think we have enough time for that. But maybe after today or maybe tomorrow sessions, if we have a cancel session or if we have a additional time like outside of the schedule, I'm happy to explain it because it's a magical technology. But you can think that it is working similar way to there was an old system named Active Directory from Microsoft. Maybe if you guys work in the corporate companies, you already know what is the Active Directory. So it's working similarly, but kind of different. It's a long topic.
Okay.
Okay. So another basic service is storage. So I will try to explain the Amazon over there, Azure over there, and the Google over there. So the most of the cloud providers has the same exactly service, but with different name. In the storage, Amazon has S3 buckets. So you can think that it is an advanced FTP server. It is a disk in the cloud. It's like Google Cloud or it's like iCloud. It's a disk in the cloud. You can just put the data on it and read the data on it. Like it's kind of a database for files. And this is extremely cheap and extremely powerful thing. You can just write petabytes of things. And also it is useful things because you can just put the videos on it and then stream the videos using with CDN. You can just put the static front-end code and just serve with the CDN, or you can just write your logs here, or you can just upload the company operating manuals in it. So it is a general storage. And Azure have Azure Blob Storage. It is like 99% similar thing. And Google also have a Google Cloud Storage. It's also the similar thing. And we have a compute. The compute is the general category of computing something in the cloud. And there's a many different services. Like I think there's a 9 ways to do a compute in a cloud, in at least in AWS. So there's many different services. Like the instance you can this is for AWS. The instance you have an EC2 instance, which is virtual machines in Microsoft Azure, and Google Compute. I think it was the name was Google Compute in Google Cloud, and you have EC to spot instance, the auto scaling, light sail, batch, lambdas. In Azure, you have the web apps, Azure functions, Azure container instances, Kubernetes, ECS, Fargate. Like there is a bunch of services. Even I'm sure that there's some of the services I have no idea even they exist, like Beanstalk, Amplify. So like generally purpose of these things are running some codes in it. For example, you can run a virtual machine and say that, hey, give me a Linux virtual machine. And you can run your application in it. Or you can just say that, hey, give me a Lambda. And you can deploy your code in it. Or say that, hey, I have this container. Please run this container. And it can run this container. But basically, most of these services top of virtual machines. So that's why we are categorized most of these services except ECR. I think it's kind of mistake over there. Except ECR, the most of them is running on EC2s and they are computing some stuff.
There is a notion of vCars, which stand for virtual cars. In these virtual machines you're mentioning, how do you decide on how many vCars are suitable for your design or purpose you're designing for?
Well, it is like mostly related with how much resource you need and what are you doing and what time you're doing. Um, I'm actually not working on the virtual machines lately because we usually running a Kubernetes. But I will adjust your question that in one Kubernetes node, how many containers I can run and how I decided. Can I adjust your question like this? Is this similar?
Kind of. My question is, how do you, because vCore on one machine could be different to vCore on a different machine, because effectively they end up on some physical server. And I'm wondering if AWS is somehow balancing this out, so vCores are equal along all the services you listed, or is it some kind of unknown variable that you have to deal with and guess?
I'm not expert on this topic, but usually the same. Like they have a different physical CPUs under that, but they are adjusting their capabilities to some standards. If you're adjusting the vCPU in the Azure and vCPU in the AWS is different or not, they completely different. But if in the same cloud provider, like the vCPU in Fargate and vCPU in EC2 is different, they are almost same or they are attempt to be same, at least as far as I know. And they're adjusting this with, so usually cloud providers has some abstractions layer between the physical layer and the services. So this layer, I don't know the details because it's like under my knowledge, but there is some kind of way that adjusts like the managed CPUs and limit the CPUs for giving the same performance. But for example, if you're running database, they usually in Azure they usually say you some different measurements. So if you run a database in Azure in some certain way, they are not giving you amount of vCPUs. They give you S key something or DT something. So if the measurement is different, they just usually say the measurement is different. Okay, and also networking. So we talk about networks this morning, and all of the things we talk, you can just do virtually. So you can just say that, hey, I have a VPC, and inside my VPC, I have different subnets. And this different subnets has like different purpose machines. And these connect each other with using like different firewalls. And also there is some internet gateways And also there's some network devices like DDoS protectors or like other kind of things that like basically like uh, advanced firewalls. But what I'm trying to say is what you can do with the Cisco devices in your house, you can also do the same thing in cloud, but in couple of seconds. Do you want a firewall? Just say, hey, give me a firewall. And in couple of minutes, you have a firewall. If you want to say, hey, I want to like separate my network to two subnet, you can just say, hey, separate it, and then you have a two subnets. And for dealing with this, the networking stuff, you have a many different resources you can deploy in the Azure or AWS or Google Cloud. And also the databases. So for hosting database, you usually have a couple of ways to do it. You can just rather run an EC2 instance, a Linux machine, jump in it, set up a database by yourself and run it. You can either put the database inside the container, you can put it in Kubernetes, you can put it in container instance, you can put it in Fargate and run there, or you can just get a managed service. And the difference between this is in the one level, you say that, hey, give me a machine and I will set up a database in it. If you do that, the all responsibility of the data and the all responsibility of this database is on your hands. The cloud provider only responsible for the machine itself. But also you can say this, hey, give me a MySQL instance, Postgres instance, or Oracle instance, or even a MongoDB instance, and I don't care what type of CPU you run, what type of machine you run, what type of operating system you run, or what operating system update you set up these servers. You just give me a password, username, and a URL. Obviously, this is expensive, but imagine that you are running a company and you have a database, and in this database, there is information that how many users have how many free coffee in the mobile application. And some people just purchase like 100 coffee and they have a 10 free coffee coupon and you just lost it because you are running EC2 and you forget to do a security update or you just accidentally do something. So usually in the industry, if it's production, we are happy to pay this cost and we are running RDS. RDS is the name of the general relation databases in AWS. So take my money and give me a database and give me the guarantee that this data will always be here and no one will accidentally delete it or no one will access this database if I do my firewall rules correctly. But if the company is big enough to hire a database security team, they also usually like run their servers and deploy their databases. But most of the cases, if the company, even the company has 200, 300 people on it, they usually use one of these services. And also containers, my favorite part. For running containers, we have a couple of different ways to do that. But I think the most popular one is like running Kubernetes. So Kubernetes is actually a container orchestration tool, which we will cover all Friday. And you can run Kubernetes as a service in all of these platforms. Like you can run in AWS, you can run in Azure, which will do the demo in Azure with this Kubernetes. And also you can, of course, run in the Google as well. So in this way, you just say that, hey, like in a database example, I don't want to get the machines and set up Kubernetes myself. Give me a running Kubernetes cluster and I will connect it and I will run my containers in it. So this is the most common way. And also there's some services I really like ECS or container instances. So these services, yeah, question?
Kubernetes means like running a container in the cloud.
Oh, no, it's actually Kubernetes is a product for orchestrating your containers. You can run Kubernetes in your own servers, even in your MacBook. You can run Kubernetes as well. Kubernetes is a tool for orchestrating your containers. Imagine that you are doing a microservices and you have a 300 microservices, and this 300 microservice has to be at this 3 replica in a given time. And this means that you have to run a 900 container in your servers. So running 900 container by hand is not an easy way. That's why we have a Kubernetes for orchestrate and automate this process.
So if you have 900 containers on your own personal machine and you want to make those microservices available, Kubernetes will allow like another outside computer to connect to each microservice individually.
Yes, technically possible, but I'm not sure how much you pay that amount, that computer which can run a 900 containers. But technically possible, but I'm not sure if financially it's possible. But technically it's possible. Like you can just like purchase a data center rack like Dell machines. You can run Kubernetes in it. You can just put all of the network resources, and then you can run a Kubernetes in your home and service the whole world. It's technically possible, but we usually not do that. Yeah. So, and also there's another ways to run containers in the cloud. So Kubernetes is usually overkill for startup cases. Kubernetes is really cool, but it's expensive. I'm not mean it's expensive by cloud providers. It's expensive by the consultant's fees, or it's expensive by the human resource you have to allocate for the setup that cluster and to manage this cluster. So, by the way, probably the Kubernetes is cheaper than the ECS in probably after maybe 50 containers, which is running 2 gigabytes RAMs and 1 CPU. Kubernetes probably will be cheaper. But the Kubernetes has their own expertise, and running Kubernetes in the production, it's not easy because the Kubernetes is complicated tool and it has a lot of complicated configuration. You can just run a Kubernetes in your computer and have a fun, but if you want to do this in production, either you have to be professional about this or you have to have a team that who can help you with it. So usually hiring this type of people is expensive. That's why Kubernetes is expensive. But also, if you are a Kubernetes expert, it's help you to get the great jobs and it's help you to have a good income. But it's not easy. So, yeah.
Is there a simple alternative?
Yes, there is. For example, my favorite one is ECS Fargate. ECS Fargate is basically the similar thing, but not that much complicated. So basically, you just have a container and give the container to AWS and say, run this container for me. And they will run this container for you. And you can say, run 10 container for me. And they can run 10 containers. And you can just give a task definition file with 100 containers, and you can just say, hey, run this 100 containers for me. And they will help you to run all of these containers for you. And it is easy to configure. It is easy to understand, like it's more easier than the Kubernetes, and it is cheaper to start with it. Like with $100 budget, I think you can run a ECS cluster and run your servers without having that much of expertise. But also downside, if you are running a bunch of containers, if you're running like 100 gigabytes of memory and maybe like 200 of the CPUs, ECS will become expensive super quick, and you will start to feel that you don't have too much control on how this generally running. And also, it is the similar with the Azure container instances. And also, I don't know the name, but I think Google also has the same thing as well.
I was wondering,
Docker Compose versus Target. Where do you draw the line? Which one
Yeah.
is worth it and what?
Yeah. So actually, technically, they do similar thing, but in different sizes. So in Docker Compose help you to like run couple of containers together in some kind inside of some kind of network and help you to manage these containers. But it's a low scale example. If I draw the line with ECS, I will easily say, I mean ECS Fargate, nice ECS EC2. In ECS Fargate, you don't have to manage the physical server layer. So this means that you don't have to do the Linux stuff. You don't have to manage the Linux stuff. You don't have to like log in the server, the SSH server, and run commands in the CLI. You don't have to do that. You just give the AWS and hey, run this for me. But the Kubernetes, if you get the managed Kubernetes service, it is similar. Yes, you still don't play with the command line tools. You don't still play with the machine itself. But it's basically similar thing. If you have a small startup, you can just run an EC2 or virtual machine, Docker Compose all your repositories, and then you will work.
When would you say is the time to move to Kubernetes or Fargate?
Well, usually I'm suggesting my customers, startup customers, to start with ECS or Lambda, and then after it start to be expensive, just go to the Kubernetes. But for Docker Compose ECS, when you feel like your job is important, the business important, the businesses makes enough money, and if you just stop servers in one night, you will lose a bunch of money, then it's time to go there. Because if you're running a Docker Compose in EC2, I will not trust my couple of $1,000 company to run inside EC2. Okay. I will just quickly finish that. And also we have a CDN services, content delivery networks. So these are actually like text what you have to the whole the world. For example, we talk about the S3 buckets, and I say that you can just put a video and you can just stream this video out. And imagine that you want to stream this video in 180 countries in the world. So you can just use a CDN solution like CloudFront or Azure CDN or Google CDN, or maybe CloudFront from front door from the Azure. The all name is really similar. And then if somebody accessing your website or accessing your video content from the Korea, you can just respond to the server inside the Korea. Or if some person try to access your website from US, you can just respond from the US server. When you publish a content in the S3 bucket with the CloudFront integration, your content will be copy all of the H resources. H resources, I mean the different data centers in the different countries, and when you access it, you can access there. And also we have a supporting services, and these services are like bunch of things like secret managers, the log tools, the alerts, a bunch of machine learning tools, like any kind of tools that can help you to run your cloud. Since we are over time, I will not explain this, but I think the next sessions, while we're doing a Terraform, maybe we can do a couple of examples with it. We have a questions part, but I'm not sure if we have enough time.
We have a long lunch today, so you can go over.
If you have a couple of questions, I can take it.
Yes, storage.
CDN and what?
Storage.
Storage. Okay. Okay. So storage, you can imagine that it's the entry point. You just put your file in the storage, and your file is the same region with you. If you don't use a CDN solution, your file will be only in one region. But if you use a delivery network, and you say that, hey, I want to deliver this in whole of the North America, and this means that the file you put there will automatically copy without your control to all of the data centers in North America. Yeah. And also one of the thing is like, can I create a storage account in all of the regions and do this manually? Actually, you cannot do that as well, because most of the cloud providers has ghost edge locations. For example, Turkey is a big country and Istanbul is not capital but center of the country, but there is no Google data center or there is no AWS data center in Istanbul. But if you put a file inside the S3, and if you run in a CloudFront configuration, you can see that if you try to access this file in Istanbul, you can see that it's actually coming from some data center in Istanbul. Because even sometimes cloud providers don't show in their maps, and sometimes if it's not publicly available, they still have some kind of ghost data centers, like really small data centers only for CDNs in some countries. Yeah.
Questions?
Okay. So thank you for listening to me. And reminder, please set up a AWS Azure account, not AWS, and set up a Terraform to your computer, and also set up Azure CLI to your computer for next sessions.
You just search online, you can find it. They have a little script you can use.
Can we go with alternatives?
Sorry?
Can we go with alternatives like?
You can try, but it's not gonna be supported. If you run into issues, we're not gonna see time for that.